Hi, I'm Jay from Real Street Performance. Today we're at FFRE with Brett LaSala's Coyote engine. This engine is fresh off of his 2023 Sick Week win. He went to race it the following weekend. It picked up a noise under the driver's side valve cover, so he came down to FFRE to see what the noise is and get a look at the engine's overall condition.
This is a new platform that we're trying, a stage 4 engine that we're testing out. It's a GT500 short block, Boss crankshaft, a set of MGP connecting rods, Manley pistons, and Trend TP1 pins. And we're gonna disassemble this guy and see what it looks like so we can make them better.
We're excited to see the condition of the engine inside with the first time running aluminum rods. We put this engine in the car before World Cup finals this past year. Has over 50 track passes and 1,000 street miles during Sick Week. And up until the little noise, it's showing no sign of giving up. We run the engine at over 48 pounds of boost every pass, which makes 2,500 horsepower in the hub dyno. So the fact that we've come this far with it and see how far we can go, I'm pretty pumped about it because I'm gonna go faster. Run a Plasma Man intercooler and intake manifold on this car. The billet Coyote intake manifold from them, I trust them, I trust the intake. We've never had any failures from it or leakage or anything. They worked with us towards the beginning of our relationship on a few different runner designs and lengths, and this was basically the end product, which is what is offered to everyone. If you just go on the website, it's the standard manifold, and it's just been awesome. They've been great to work with.
When you deal with, you're at the racetrack and you're looking at a welded seam piece that's split open and they're trying to beat it back together to meet around, it's an avoidable problem. You buy a quality component from a group of guys that accept racer feedback to build a better product, and then you just, as the end consumer, you just get to enjoy that good product. You don't have to be part of a beta test. You just buy the best stuff and you got the best stuff.
And that's one of the things I've learned a lot since working for you at Real Street is failures at the racetrack. You save $100 because you use this plastic CO2 line, and then you just spent $2,000 going to Texas, and now you lost the finals.
Yeah.
And how much money did you save?
Yeah.
And the memories.
Yeah. The memories are really what you're paying for, because you're only going to play the game for so long. So you want the best outcomes you can have. That way, when you look back on it, it's not a bunch of times you almost did it.
I think the biggest thing about the Plasma Man intake is it fits every time.
Right.
So it's O-ringed, you don't have to worry about anything. They're flat when they're all bolted together. They're flat, they don't leak, right? So a lot of other intakes, once they get up to a certain amount of manifold pressure, they leak, and the Plasma Man does not do that. So it stays flat, it bolts up good, it works.
Yeah, it doesn't change shape.
Doesn't change shape.
Yeah, I mean, some of these components, even though they look very strong, they will change shape in service and not go back to where you pull something off, you can't put it back on because now it's not the shape it once was.
Sure.
How much noise was it making?
It was just a tapping. I heard it, the exhaust is so loud, it's hard to hear the engine, but in the car with the helmet on and the windows up, you can kind of hear it more. It was like a light tapping noise, and then when I took the hood off and went to it, I could hear it on the driver's side of the engine and not the passenger side. Mainly at idle the most.
The crankshaft gear looks really good, timing gear. We've been seeing a lot of fretting on the front of this gear from the snout to the gear itself. Yeah. Because the balancer starts to move around, whether it's, the fastener not staying put or whatnot. That looks really good.
Yeah, I saw the nose of the crankshaft out in the shop. It looked pretty terrible.
Yeah. And we cycle them out. Even if you don't see a lot, like this crankshaft will just get cycled out.
Well, again, the timing chains. The belt takes all that noise in.
Once
and
they start
exhausts
moving,
it. The chains
tons of harmonics.
are just
Yeah, tons of harmonics for sure.
Yeah. You can see the vibration from the front cover.
Absolutely.
And the chains, previously you'd pull them off and they'd be all kinky.
Yeah,
they're
overworked.
Overworked.
Well, this, looking down this, looks very uniform. When we first started working together, the chain mess was...
It was a mess.
It was a mess. When you look at a video and then you see maybe for an engine that has a secondary idler on the timing belt, and the guys think that by making that timing belt more firm where it can't exhaust energy into it, it makes it better. It's like, well, it needs to exhaust the energy so it doesn't break stuff. So when you're dealing with chains, it's a lot harsher than a belt environment because it's just metal. You know, you're driving all this noise into metal versus driving it into the rubber, and the rubber will dissipate it as a dampening effect. It's pretty awesome how far this engine has come from its predecessors.
For sure. We started building these with Brett in 2015, and we never ever thought that we would take the Coyote-based platform that far, right? We had built a lot of big engines that were capable of doing this, but never anything that was 300 inches, stock block, stock head castings, stock crankshaft, you know. Never did we think that we would take it quite that far, but we've just perfected it each step of the way.
Well, the early 4 valves were big, a lot of parts,
Sure,
a lot of bolts,
different
not
parts,
a lot of power.
different parts too, from engine to engine and whatnot.
But they had the funny, you know, the B-headed engine with the 2 different intake ports. They were trying a lot of things.
Sure.
And they weren't proud engines. This is, you know, in naturally aspirated form, this thing is killer. The first time I drove a Coyote, I had at the time I had a V10 M5, which it's got 10 cylinders.
Yeah.
And and Gio had a Coyote Mustang, and I remember driving his Mustang, and I was like, how does it run so good? It's got 2 less pistons, and you know, like less airflow, less. But the Coyote is just a really good running engine.
Sure.
They have the people involved in this have a lot to be proud of as far as turning that around, because the early Mod Ford stuff, and someone may, I'm not talking bad about them, it's evolution. They started somewhere to get here, and I'm glad that they got here, because where they started wasn't nearly
Wasn't
as
that good,
fruitful.
yeah. No, it's a killer piece. Even this in its stock form is pretty amazing. You know, for us to be able to make, let's be real, you know, 2,900 horsepower with this thing, to be able to run 50 runs, 1,000 street miles, go through that many heat cycles with it, right? And it still stay sealed up, is pretty impressive. That's something that you don't really see very often.
Do the valve tips wear pretty evenly on these engines?
They wear pretty good. The only time that we've seen any problems is if it's running on the limiter real hard. It'll have a tendency to move the tip of the valve and try to chip the edges of it.
More on the exhaust or more on the intake?
We've kind of seen it on both sides, to be honest with you. Okay, I think we might have found our problem, boys.
Yeah?
Looks like it's gonna be this guy right here.
Oh, it's been converted.
Yeah, into a two-piece. There she be.
Okay. Well, it's a good thing we stopped running it that day.
That's it. That's our problem. Looks like it pulled the dowel out of it. Let's see what other. It looks like it scuffed that journal up. Those 2 journals right there.
Oh yeah,
So
smeared that material around.
Smeared it around. So we'll have to check this cam for straightness. You can see it's gotten hot. So it was running that way. That didn't just happen.
And you can't really hear it that great over the
Of course not.
turbos.
This won't make a lot of noise because it's aluminum, right? It's not really making any knocking or banging noise or anything like that. This is very faint sound, but if you look, you could see where it has discolored the cap and turned it a little bit of a darker color. That's the actual oil getting hot and staining it. So this didn't just happen. This happened within probably 2 or 3 runs.
Yeah.
Realistically.
Is that head smoked or can it be
Oh, it could be
line-owned?
fixed, yeah. It could be fixed, no problem. We'll put a new cap on it. We bore it for the new cap, and it's no problem. We just got to determine why this happened. Normally when takes something like this and wipes it out, it's a piece of material getting through it, you know, deforming of the area, but all the other cam bores look perfect. It hasn't wiped the bore completely clean, so that's heat. It's grabbing a hold of it.
It's moved a lot of material.
It's moved a lot of material, particularly from the cap. So it could be the cap itself deforming.
So could it have deformed the cap and then cause that?
100%, yeah, it runs out of clearance.
Whereas we didn't just move to the billet,
Yep.
billet cam caps?
Yeah, just runs out of clearance is all that it is. So we could go to the billet cap. They're only held in location by these little dowel pins, you know, and you can see this one's deformed a little bit actually.
Or just tried to pull the bolt?
Tried to pull the bolt's bent. You know, the bolt's bent, so yeah, that's definitely what's happening there.
Yeah, this another thing that's really neat about this engine is the components are relatively affordable and they're still in production, so you're not having to search for old core items, which is a major problem in a lot of the engines that I've really enjoyed for a long time. Is the core parts are drying up and you get into this Ford game and you can get cores.
You could get it. That was one of the reasons why we took this platform on, Jay, is because we were able to source the parts.
Yeah.
Right? You and me have both been down the 2J game.
Yeah.
Right? How difficult is that?
It's getting more difficult.
You know, to be able to source good, usable cores. When you do get them, how long do you have in getting them right?
Right.
You know, so lifters.
Well, yeah, I mean, Ford G63, SR20, 2JZ, 3SGT, they're all dry. They're
Drying up.
It's not the 90s anymore. You know?
You're right about that.
It's not the 90s anymore.
So as you guys can see, we're running a copper head gasket on this engine. Doesn't look like it's comprised at all. It looks fantastic.
Yeah, we never saw over 10 psi coolant pressure. It's a pretty, you know, part of the maintenance between runs is looking over the data logs and literally looking at every sensor that's on the engine in the car, cam position, coolant pressure, oil pressure, make sure that it's the same. You know,
Sure.
It's the same as the last time we ran it. It's not developing anything. And coolant pressure was always right in check.
How did you guys, you know, deal with the car as far as from track to track, maintenance wise? Like, what was the routine to keep this thing? Because obviously whatever you did was correct. I mean, it's rare that we take a copper head gasket apart that doesn't have heat marks, right? That doesn't
Right.
show overheating, right? I mean, this isn't showing any of that. I mean,
Yeah, I mean, it's, on the sick week thing, the drive, I had a list involved of what it took to put the car in our street trim and do our race trim, because there were so many days, just so we wouldn't forget something silly.
Sure.
You know, we warm the oil, warm the engine, you know, in the mornings if it's cold, let it heat soak for a few minutes, you know, before we give it any kind of throttle or RPM. And that's been standard with the aluminum rod since I started running it on there. Watching the oil filter, I run a cartridge filter so I don't have to cut it open each time.
Okay.
And basically every time I change the oil, which is every track outing or two, depending on how many passes I make, you know, we'll look at the filter to make sure, you know, is there material, is it developing something, to make sure we're in the clear to try to catch something early on if we can.
it's great. I mean, it
Well,
looks,
also
it looks
only
great.
is run on premium fuel.
Oh,
So,
yeah.
like, it gets run on 1-ethanol
Sure.
as a race fuel. So
Yeah.
you're not, I mean, if you imagine customers that are mixing fuel and they don't remember 4 track outings ago that they
Had whatever in it.
Whatever in it. So they're standing there and the answer eludes them because they're part of their own problem because they don't run consistent fuel.
And
Tune-up stays the same.
well, yeah,
it's
and,
the same. Fuel's the thing.
and I'm pretty meticulous with like my starting points, and I think it comes from like my diagnostic background to be able to control our diagnostic if something happens. Like my start temps before a run are always the same. The transmission temps are
Huge.
always the same.
Huge.
Just so that way,
Consistency.
if something does happen, it's like, oh well, this time it was this hotter, you know. So we try to keep everything
Yeah.
as level as we can.
Testament of it, it looks great. So
Yeah.
all the receivers look fantastic. The wire has pushed into the receiver correctly. It hasn't really tried to show any traces under the wire or anything, you know,
So
like that.
turn it up.
Yeah, I mean, so far we're gonna check to see how the decks are and squareness and stuff like that, but possibly, yeah.
Well, at some point it breaks.
Yeah,
right,
at some
and we've
point,
known
yeah,
that going into this, and we didn't think possibly we'd get
It
this
is
far.
what it is.
Like,
Right, at some
and
point,
when
yeah.
we get to that limit, we'll figure out why, and if that's just it is the limit, then that's the limit. Then
Where's
we
that
back
gonna
it
be
off.
at?
We back it off a little, you know. But,
Yeah.
this is also in preparation for TX2K in 2 weeks. And Precision has my turbos right now, you may not know.
Okay. Okay.
And they may be a little spicier for this
Oh.
race than they were for the last race.
Okay.
Yeah, I mean, it's 7680s, and then they're going to go to a next gen 80 compressor wheel, which this engine, even at 48 pounds, you know, the pressure ratios are really desirable. So you just have a neat combination because you have a ton of airflow, a reasonable amount of cubic inches, a lot of RPM available. Like it's a neat combination of parts for sure.
Well, the power cycles in the RPM, right? Like in high gear,
100%.
going down the racetrack compared to the
Yep.
6,000 RPM of the big block.
How many can you turn before?
Right, we have more power
Yeah,
going,
you're just
more power
how many-
cycles.
Yeah.
Times can you rotate the crank? Right?
That's it.
That's what it comes.
More times you do it before you get there, the faster
Yeah.
it's going to get there. 100%.
How close are these to stock heads? How much work do you guys put into these heads before you deliver them to a customer?
You know, it's not too crazy, Jay. These things run pretty good. What we do is we take them, we pull the guides out of them, and then we go ahead and port them. We don't go crazy. We just port them to the correct cross-sectional that we need for the engine and what it's doing, right? How many RPMs the thing's going to turn? Is it on gas or is it on alcohol? So we'll port the runners based off of that. After that, we'll put some bronze guides in it. We check the cams and the housings to make sure they're all happy. And then we surface them, valve job them, clean them up, and do all of our tip heights, our spring heights, stuff like that. And that's about it. So they're great in the stock form, you know. They get a valve, an upgraded valve, a FFRE valve, a pack spring.
Is the seat pretty concentric to the guide? Like when you do a valve job, like are they a nice casting?
Yeah, they're pretty good. Yep,
Okay.
they're pretty good. What you run into a little bit is the seats are not really that big, so as far as diameter is concerned. So what we don't do is we don't run very large oversized valves or anything like that, right? The seat is only so big, it could only dissipate the heat so good, you know. We haven't gone to any of the copper beryllium stuff on these things. The factory seats do a good job, you just can't put too big of a valve on it. So.
Well, fortunately the thing moves the air well.
It moves air really good. It's
Yeah,
very,
so you're
efficient.
not there's not a hard problem to solve there. You know,
No.
like there's engines that when the bowl, if the area behind the valve seat is larger than the valve seat, then changing the valve seat offers more airflow.
Sure.
But when you're dealing with modern stuff, I mean, the guys that did this engineering at Ford, they did a good job.
Yeah, we try not to go over like 89 or 90%, right? Anything more than that, and then you could go up to about 91%, but anything more than that, and the car won't want to recover on the gear change, right? It gets real lazy. It doesn't want to recover. So you make the bowl area too big, it won't do what it wants to do. What I am noticing is this thing's dried up. If you look at the combustion chambers, they're completely dry. There's no oil on them. Good. It's not moving oil through the system. It doesn't appear.
Yeah, the spark plugs have come out clean every time. Usually you can tell when it starts to get oil in there.
Okay, good. I mean, it looks really good. You don't see any heat marks on it anywhere.
Turn it up.
Yeah, that all looks pretty good.
Well, eventually you end up with, 60 or 65 pounds of boost. Like
Yeah, really.
That would, if it will mechanically manage that, then you get into, I think, just like the glory stage. 'Cause it'll just be a lot of magic happening.
Yeah. 60 or 65 pounds, Jay?
Yeah. Well, you got guys out there running 100 nowadays. We're not, 65 is not crazy.
No. No, the rings are starting to go in it a little bit. Rod bearing.
Well, you have a dry sump.
Yeah, you got enough oil pump
Yeah.
to do what it's got to do.
Yeah. The bearing lives a much better life with lots of oil flow.
Not aerated oil.
Yeah. Frappuccino. It's amazing how well it lives for having such a short cylinder.
That's our biggest problem that we
Yeah.
fight is the length of the cylinder wall, unfortunately.
Yeah, you can't run from that without
Only so much you can do. You go taller, then
taking
you
a
run
bunch
into
of crank out of it.
chains.
Yeah.
So you could take some stroke out of it, but not many people want less than 300 inches,
Right.
right? You know, so
300 is better than 183.
I get that.
Jay's like, it's great working with such a large engine.
I know.
It's like, what
How
do you
sad
mean?
is my life that I'm excited
Right,
about
it's like
300 inches?
Never had anything 300 inches. Oh, that's funny. Yeah. You can tell the rings are getting a little bit softer. But did you see any crankcase pressures numbers going up at all or no?
No, they've been pretty consistent.
Pretty good.
Yeah.
It doesn't appear like it's any of the oiling ring or anything like that. It just looks like the top ring's just losing some tension. But
Which is just the side effect of horsepower and running.
Of heat.
Yeah.
that's it. It's just the amount of heat. There's options that you could do, you know, with a different exotic ring material that we would run in some other stuff that we've tried, like an M2 ring material, or even just going to a AP second ring. Instead of using just the AP top ring, you know, you could sometimes do an AP second ring and it'll hold some more tension in it. But
Well, the
man,
rings are working hard in this thing though. 'cause
oh,
the
real hard,
piston's
yeah,
not
yeah.
stable.
Well, and you ran it on gas too for a while for this cruise, right? So that's still sustained cylinder temperatures, right? That ring has to go
Yeah.
through, subjected to. So it's all about dissipating the heat, getting the heat out of it, and not subjecting it to too much heat to where that ring gets longer. Once it gets longer, it loses its tension. Can you catch me?
Yeah.
If we're gonna do this together, let's do it.
Oh man, this is a cool engine.
It's pretty cool, ain't it?
Yeah.
When they come apart looking so good and
Yeah,
Right,
no,
it's just such a like lackluster experience when I used to build 2 valves and 4 valves. It was like so much work for so little reward. This thing's just like parties.
she's a party girl.
Yeah, she's a party.
she's a party girl. That's how I like them. Like I said, what we run into, our biggest thing that we battle is trying to get the piston rock out of it at the bottom.
Well, there's so much action on the skirt.
On the one side only,
Yeah,
right?
it's just there's work being done. You gotta.
It is.
The crank doesn't look like it gets much prep work.
So the crank gets, if it's steel rods, gets 2 pieces of Mallory in it, one in the front, one in the rear.
Okay.
That's for around an 1,800 gram bob weight or so. The aluminum rod is lighter, so it doesn't need any Mallory, you know. It's gonna be your thrust.
Man, that's nice.
More converter pressure.
Well, yeah.
We've been playing a game with that, of not knowing,
Where you're at.
when we can stop with that, because we can manipulate the converter.
100%.
Nothing to talk about there.
Yep, that's good. We've got that.
That was 1,300% since we started. I've been counting them.
Oh, man.
And these bearings will tell us how bent the crankshaft is or not bent the crankshaft
100%.
is.
That's why I said you'll probably see some touchdown through the mains, through the center, but it's beautiful. I mean, I have more touchdown on our limited drag radial engine, Yeah, very, very, very little bit.
For the amount of component you have and the amount of stroke it has, like it's a hard working part.
Oh yeah, it's got a big stroke in it.
Part.
Yeah, 100%. No, 100%. So normally what we would see, and that's, some of it, this is just the crankshaft flexing and moving around. You see it in a little bit of the bottoms, but not a lot of fretting, so it's not trying to pull the main cap off of the block at all.
They're well located. You have a good amount of fastener.
It's decent for sure. There's a decent enough surface area. It's not a massive amount, but there's enough. And it doesn't appear like, what we also sometimes see is it try to pull the caps in and pinch them, but it doesn't appear like it's doing that at all. So that's great. Oh, thrust bearing looks fantastic, dude. I mean, it's not.
Well, that's exciting.
That's great. That's huge. Yeah.
We were literally just discussing this.
Good. Yeah,
because you don't want to get after it too much with the trans and hurt the thrust bearing.
Right.
So it's
we don't want to, we need the converter a little tighter. We don't want to change the stator, because then you start all over again. But if we can get 10 psi or 5 more psi and start, manipulating a different way.
You don't have a lot of load bearing area with this thrust,
No.
right? So we didn't know what it looked like, So now we do. That's huge. It's great, dude. It's fantastic.
How much work did it take to get that piston sorted with Manley? Was that was a team effort between you and Manley?
It was a team effort between me, Manley, Brett, Jim. A lot of guys probably were involved, right?
Yeah.
Early on, that were running these things. We ran them with 6R80s in them, and we were hurting pistons even more so.
Big gear drops, lock converters,
right?
From the ratios.
Hard. So the only damage that we ever saw was...
Say that again, because that's talking about developing a piston program, and it went right in the driveline in gear drops.
Yeah.
Because when the engine can't run from the stress, you will find the weak points. When the engine can operate in a small window where it's turning relatively quickly, you can get away with more power. That's just it. This engine, if you could make 2,500 horsepower at 5,500 RPM, this thing would be on the ground in pieces. It's running away from the stress. It's RPM.
This engine can't live under a 6R80 ran wrong. It won't live. It just probably won't live if you run it on a 6R80
because you're pulling it down in RPM range.
That's not down so hard.
Yeah.
Doesn't have enough stability in the skirt.
Well, we're starting to see that. The guys in the import crowd are finally starting to understand why the Power Glide is not the unit of choice.
Sure.
And you try to tell them, a while back, and nobody wanted to hear it yet.
Because it was too easy. You
right,
just go get it for,
You want to have reasonable RPM drops. You don't want the engine to climb back out of a deep hole to get to the next shift point. You want it to kind of be more of a relay race than a start-stop race.
To get there. Yeah.
And that goes right into the crankshaft revolution talk,
Sure.
The more times you spin it, the better off you are.
This looks really good, guys. So we'll set a bore gauge, we'll check the cylinders and see how round they are. See what the cylinders, we're already gonna go to an oversized, 99% of the time when we freshen these engines up, we go to an oversized piston. Not only get the cylinder wall straight and round, but the ring lands on the pistons take a massive amount of heat and they move. So if you have a piston that's still good piston to cylinder wall clearance and you put it all back together, that engine might be down 30 or 40 horsepower just because the rings aren't flat. They're not squared. You put a new ring in it, it's got to deconform to that groove and whatnot. So, we'll put a new set of pistons in this, a new set of rods, obviously.
Yeah.
But it looks like it's in pretty good health.
That's cool.
It's really cool. Yeah, it's cool. It's real cool. Now obviously there's no torque plate on it. So the top will be moved around, right? Shows the top pinched a couple of tenths. They're straight as, you know, they're straight, man. This is half a thou big. The zero's half thou big.
Yeah.
Right? Because I had him put it in there with
heard
half. Yep. So, pretty impressive, huh? That was a couple tenths. And here's the deal. When you check these bores, okay, you check it this way and you check it this way. If that thing's within a half a thou or a thou, it's fine. But if it's 2 thou and a half thou, it's cracked. And it's cracked behind here.
Behind the engine block has given up behind the
Engine
sleeve.
block's given up. So, and we have seen that. I mean, it happens. So like this thing's within a couple tenths, 4 tenths, 5 tenths, you know, half a thou. It's pretty damn good, man. That's pretty good, man. We've taken this engine apart, we've inspected all the pieces, everything looks really, really good. From the cylinder walls, to the cylinder deck, to the pistons, to the rods, to the bearings, everything looks fantastic. We're gonna change some things around. We did have a failure in the cam cap area, so we're gonna go ahead and put some billet caps on it to eliminate that from happening. But other than that, this thing's gonna get a new crankshaft, a new set of MGP rods, some Manley pistons. We'll reuse the TP1 pins over in it, some new total seal rings, and get this guy back together for you.
Yeah, heck yeah. And then we'll keep the same approach we've had. You know, we'll go keep at it, and then you know, add a little power as needed, and then see what it looks like next time.
Yeah, that's right. That's right. So, what do you think about this thing, Jay? What's your thoughts?
I'm excited to have a successful head gasket sealing. I'm excited to have the airflow. You know, like when I first started helping Brett and Jim, the airflow was probably the biggest thing to get attracted to, because the JZ doesn't have great airflow.
Sure.
You know, it's just tough.
Yeah, sure.
But this has great airflow. So if we can stay away from the part that something mechanically fails, and it will just be a failure. Maybe it's the crankshaft, maybe it's the engine block. You know, just a failure that couldn't be avoided because of power level. I think that we're doing a very good job of working our way to that point, because we have now run the engines at different power levels. We have good tuning of the engine. We're using the Motec box. We have good rev limiter algorithm. We have good pattern control. The timing is being executed good on all 8 cylinders. Like, we have a good running engine. So we're gonna put a little bit bigger turbochargers on it and keep working our way up. And eventually we're gonna find a point where we either don't want to go any faster. I mean, the car's very fast.
We won't get there. At least I'm in my car.
Well, what are you gonna do? Like, what are you gonna do? That thing goes 630. Like, if it's going 630, it's like, what are you gonna do? You just right. So at some point you're like, okay, this is the party, right? So I'm excited to be working with a group of people that are willing to edge to that line, because a lot of guys in the industry are they get excited and they want to have a glory run. They want to, you know, if there's a bigger nitrous jet or more boost available, they just want to get right after it, and things break before they get optimized. So really the neat thing that's happening right now is we're optimizing something, and it's going to get to the point where when it finally gets to its yield, we can say, we checked all the boxes, we did it methodically, we did it intelligently. That's what that thing does. And be happy with it.
That's right.
Yeah. There's nothing to be mad at, for sure.
Correct.
You know, if even this is the power level out of this, like, it's
it did everything we should have done.
Oh yeah, I mean, most of the people that have been in this industry for a couple of decades look at this, and there isn't a point to be condescending or negative about its achievements. You would just say like, that is an incredible engine. And the guys that are new to it and they don't know what they're comparing this to that, and they're lost in their own ignorance, and that's okay because we all learn at different rates. But this is an exciting program for sure, and I think that it's got a lot of great people around it, and I look forward to racing it more.
Absolutely.
Yeah.
All right, so the next step is we're going to take this block and we're going to bring it out of the machine shop. We're going to clean it up a little bit. We're going to put it in the CNC and we're going to probe it out. What that's going to tell us is where the decks are at. If it's trying to spread itself, it's going to tell us the deck heights, how off they are. And it's also going to tell us our cylinder locations to see if any of those are moving as well. So we have all that data from when we built it the first time, so we'll be able to tell what's going on with it. All right, guys, so we've put the block up in the machine and we've probed the decks to confirm the deck angle is correct and it's not trying to spread the block apart or do anything like that. And we've got half a thou, 4 5/10 of variance. So, about half the thickness of the hair on your head. So it's doing what it should do. It's staying put. It's not spreading or moving apart.
I hope you've enjoyed this video. A lot of neat information to digest and a lot of things to be excited about as we move forward with this Coyote engine program. If you're in the market for a Coyote engine, feel free to reach out. We do stock FFRE engines at Real Street Performance. Thanks, and we'll see you next time.